This lecture is about AWS CodePipeline, the service which connects all phases of AWS developer tools. We will discuss what it is, how it works, and then we will have a lab session to build a continuous deployment pipeline to release changes to the UI which we had built and deployed in our previous sessions. All right, let's get started. AWS CodePipeline is a continuous delivery service provided by AWS to automate the steps such as build, test, and deploy required to release your software. We can build a workflow of different steps involved in continuous delivery or continuous deployment. So each step in CodePipeline workflow is referred to as stage. For example, build is a stage or deploy is a stage. So these stages in CodePipeline workflow gets executed sequentially. So if one stage fails, CodePipeline will not transition to next stage until the stage has been fixed and retried. Each stage will contain one or more actions. Well, action is a task performed on the artifact in that stage. For example, building the code using code build is an action, or deploying using code deploy is an action. Actions occur in a specific order, in sequence or in parallel, as determined in the configuration of the stage. Following are the types of actions provided by CodePipeline, which are source, build, test, deploy, approval, and invoke. We know what source, build, test, and deploy are. We have seen them in the previous lectures. But what are these approval and invoke? With AWS CodePipeline, you can add an approval action to a stage in a pipeline to the point where you want the pipeline execution to stop so that someone with the required AWS IAM permissions can approve or reject the action. If the action is approved, the pipeline execution resumes. And if the action is rejected, or if no one approves or rejects the action within 7 days of the pipeline reaching the action and stopping, the result is the same as the action failing, and the pipeline execution does not continue. And with invoke action type, you can invoke an AWS Lambda function if you want to perform certain cleanup tasks or pre-build tasks, etc. For example, you can use AWS Lambda to backup resources before building or deploying by creating an AMI snapshot. Every action has a type. Depending on the type, the action might have one or both of these following artifacts. An input artifact. It's basically a set of files it consumes or works on over the course of the action run. And then we can have an output artifact, which would be the output of the action. Example of these artifacts could be, let's say in build phase, input artifacts are the source code from either code commit or GitHub, etc. And output artifacts can be the build package. And these artifacts are stored in an S3 bucket named CodePipeline, hyphen then the region in which you are spinning up the code pipeline, and your account ID. But you can also choose to store the artifacts in any bucket of your choice. But if you choose to, make sure the role you assign to the code pipeline should have access on the bucket you choose. But for the default bucket, if you create the role while setting up the code pipeline, AWS automatically assigns the permissions on the default bucket. We will see this during our lab session. And then you can connect directly to AWS CodePipeline through a private endpoint in your VPC, keeping all traffic inside your VPC and the AWS network. All right, let's see how this works. The main job of AWS CodePipeline is to automate the deployment or delivery, right? So when a developer commits to the source code repositories, any of the following can be used to trigger the code pipeline. First one is CloudWatch events. It's basically a rule that is created during pipeline setup, which detects the source code changes and then starts your pipeline, which has been added as a target to the event rule. We will see this during the lab session. And when you create a pipeline that has a GitHub source, CodePipeline creates a webhook. A webhook is basically an HTTP notification that detects events in GitHub repository and connects those external events to a pipeline. You can also use CodePipeline polling, wherein CodePipeline does periodic checks and starts the pipeline whenever there are any changes to the source code repositories. Or you can simply use CloudWatch Scheduler, which can trigger the code pipeline based on a certain frequency, let's say once an hour or once 30 minutes, etc. So once the code pipeline has been triggered by any of these events, it starts executing the workflow in a sequence of stages. Let's say we have a source stage wherein we have to provide one or more actions. These actions will generate output artifacts, probably a zip file of the source code, and uploads it to the S3 bucket. And once a stage is completed, it then starts the next stage using the output artifacts from previous stage as input artifacts to the current stage. Let's say we have this build stage, and then we have the test stage, and then the deploy to the staging. And if you need approvals before deploying to production, you can add approval stage and an action which will halt the pipeline until the approval is complete. And once approved, the artifacts can be deployed to production and customers can start accessing the changes made by developer. So with AWS CodePipeline, we automate entire development to deployment workflow, the continuous deployment lifecycle on AWS platform. And the cycle goes on whenever there are any changes committed to the source code repositories. There are a few best practices listed in AWS documentation for CodePipeline. So I have listed them here. So for CodePipeline resources, when we are using Amazon S3 source artifacts bucket, best practice is to configure server-side encryption for artifacts stored in S3 for CodePipeline by managing AWS KMS managed keys, which is SSE KMS, to keep the artifacts secure. Also, you can make sure you secure the bucket using the required bucket policies. And for GitHub source repository, configure GitHub authentication using an AWS managed OAuth token or a customer managed personal access token. And for monitoring and logging best practices, use AWS built-in logging features to determine the actions users have taken, which are AWS CloudTrail to log AWS API calls and related events made by or on behalf of an AWS account. And AWS CloudWatch events can be used to monitor your AWS cloud resources and the applications you run on AWS. And the best practices for the Jenkins plugin. You can use a Jenkins build provider for your pipeline's build or test action. So when you use Jenkins, install Jenkins on an Amazon EC2 instance and configure a separate EC2 instance profile. Make sure the instance profile grants Jenkins only the AWS permissions required to perform tasks for your project, such as retrieving files from S3, etc. All right, let's have a lab session to build a continuous deployment workflow for the code we have been using in our previous developer tools lectures. Hello and welcome to this lecture. So before we build the pipeline, what is the artifacts that flows across the pipeline? Our code which we developed, right? This is the React code we have been using all the while, a simple UI which displays user information, which are stored in DynamoDB and served via API gateway. Again, all this has been discussed in API gateway lectures in detail, so visit those lectures if you have not already. And there are no changes to the actual code, but I changed this appspec.yaml file, which will be used during our deployment stage. I have added this new hook before install to clean up the existing code before the deploy stage installs the latest revision of the code. Well, this is required because using AWS CodePipeline, right now we do not have an option to overwrite existing content. So I'm using this script to delete everything under HTML directory so that when we install the latest revision, there is nothing in it and the code pipeline will not fail. Let's go to the AWS console and search for code pipeline and let's click on it. You can list all the pipelines in here. You can create multiple pipelines for different deployments. So let's create a pipeline by clicking in here. Well, first step is to provide pipeline settings. So let's give it a name. And here is where we provide the role, which will be used by AWS CodePipeline to call AWS services on your behalf, such as S3 to upload and download the artifacts. You can either choose to create a new role so that AWS will create a new role and assign required managed policies, or you can choose an existing code pipeline service role. And if you do so, you need to make sure that right policies are assigned, otherwise pipeline execution will fail. Let's leave it as new service role. And here is where you get to choose the S3 artifact location. Default is a bucket which we discussed before. Otherwise, you can choose a bucket of your choice, and you need to ensure this above role has access to this bucket. Otherwise, the code pipeline execution would fail. Let's leave it as default. So when you create the pipeline for the first time, this new bucket will be created automatically by the code pipeline. And next step is to choose the source where our code resides. So these are the options we have, which are AWS Code Commit or Amazon ECR, Amazon S3, and GitHub. With GitHub option, you can connect to GitHub and grant access to code pipeline so that the GitHub commits will be uploaded to S3 as artifacts. And to trigger the pipeline, with GitHub, we can use webhooks or AWS CodePipeline to poll for changes. Remember, recommended change detection option is webhooks for GitHub. You can also choose S3 as input source, where you need to upload the source code and provide the key in here. And with S3, CodePipeline can detect changes via CloudWatch events or CodePipeline polling to start the pipeline. You can also use Amazon ECR repository as a source stage. Well, Amazon ECR supports private Docker repositories with resource-based permissions using IAM so that specific users or EC2 instances can access repositories and images. Well, since we already have our code in AWS Code Commit, let's choose Code Commit and choose our repository in here and the branch name as master. And even for code commit, change detection options are CloudWatch events or code pipeline polling. Well, if you have observed carefully, for all the sources, AWS code pipeline polling is not a recommended approach. So choose webhooks if you are using GitHub or CloudWatch events wherever applicable. And next step is build stage. We can either choose code build or Jenkins. With Jenkins, you need to provide the provider name you configured in the Jenkins plugin and the server URL where Jenkins has been installed and the project name you created in the Jenkins plugin. So before you configure Jenkins in here, you need to set up AWS CodePipeline plugin for Jenkins and configure so that Jenkins will be detected by AWS CodePipeline. For our demo, let's choose AWS Code Build and then the project name which we created in our code build lecture. Okay, next step is deploy stage. So for deploying the code, we have these many options, which are CloudFormation or Code Deploy or Elastic Beanstalk or OpsWorks Stack, Service Catalog, Alexa Skills Kit, Amazon ECS, and S3. If you choose CloudFormation, these are the actions available. Could be to create a stack or delete a stack, etc. And if you want to create a stack when the deploy stage triggers, you can provide the CloudFormation template to be used to create the stack of resources. And let's say if we choose Beanstalk, we can provide the Beanstalk application and environment to which we want to deploy the latest code revision. But for our demo, let's choose Code Deploy. And then let's choose the application and the deployment group which we created during our Code Deploy demo. And let's click on Next. And then let's review the configuration. And let's go ahead and create the pipeline. Well, as soon as the pipeline is created, the workflow gets triggered. And here you can see the first stage, source has started executing. While the execution of source stage is in progress, CodePipeline will take the latest commit revision and uploads the artifacts to S3 bucket. Let's give it some time to complete. All right, source stage execution has completed. And if we look at current revisions, here is the latest commit information you can see. And the next stage, build has started. We can watch the progress by clicking on the details link in here. It takes us to the code build console and to the build which is currently getting executed, wherein you can monitor the build progress. Let's also give it some time to complete. All right, the build phase execution has been completed as well. If you look at the code build details, we can see the build has been succeeded. And then the next stage, deploy, should start. Meanwhile, let's take a look at S3 bucket for artifacts. So this is the bucket which has been created. And if I refresh, it creates a folder with the pipeline name. So you have different folders for different pipelines in your account. So if I click on it, we can see the artifacts folder for different stages. So the source artifacts in here contains the compressed version of our latest commit from code commit. So if I download this and open the zip file, there it is. You can see our source code. And similarly, if I go back to build artifacts folder, this is our code build output. And if I download this as well and open, there it is. You can see our code build output, which is required for code deploy to deploy onto our EC2 instances. So if you go back to AWS CodePipeline and to our pipeline, well, deploy stage is still running. We can watch the status by clicking on this details link. This also takes us to code deploy console and to the deployment which is currently running. Well, I'm using the same infrastructure as was in the AWS code deploy lecture, and I'm using the in-place deployment type, which are a couple of EC2 instances under a load balancer. So if you go to EC2 and to the instances, there it is. You can see our two instances running. And if I go to the target groups and select our target group and go to targets, you can see our instances are draining out from the load balancer. So let's go back to the code pipeline. This is going to take some time to drain instances from load balancer. So let's come back after the deployment is complete. All right, deploy stage has been completed. And if you visit our load balancer URL, it works fine. This is how entire pipeline gets executed. But what we have seen now is pipeline getting executed when we first created it. It picked the latest code revision and deployed. We already had the same revision deployed before, nothing new. The real advantage of continuous deployment is that the code gets automatically deployed when we make changes to our code and push it to the source code repository. So let's quickly make some changes to this UI. Let's add a title heading here and let CodePipeline handle the deployment. Well, before we make any changes, let's quickly take a look at CloudWatch event rule, which triggers the CodePipeline when a change is made to the source code repository. So let's navigate to CloudWatch and rules under events. So when we created the pipeline, at source step, we chose Amazon CloudWatch events as change detection option, remember? So AWS CodePipeline will create this rule for us. Let's open this. You can see it had set a pattern. So when this source AWS code commit has a repository state change for this particular repository, and if the change event is reference created or reference updated on the branch master, it triggers this target, which is our code pipeline. This is how any commits we make to the configured source code repository will kick off the CI/CD pipeline on AWS. So now let's go to VS Code and quickly add some code. Please be patient for next couple of minutes if you hate coding. Let me go to app.js file. Let's add a simple div and a class name as, let's say, title, and ID as, let's say, user-title. And let's add some header in here. Let's say the value as user details so that we can see it in the UI. And let's also add some styling. Let's add a class in this app.css, which should be only applicable to h3 tag. Let's add a color attribute and padding value. Let's keep it as 20 pixels. All right, let's also add a test case to ensure our new changes should exist before the code is built. This code in here simply checks if the element with this ID exists with this class name. All right, let's quickly run the test to see if all okay. There it is. All our tests has passed. If you remember, our previous test cases were 7 and now we have 8 and all of them passed. Now let's push this to code commit. Let's run git add dot and let's see the status. Our 3 files are ready to be committed. Let's do git commit -m and let's give some message so that we can see in our code pipeline. All right, let's push this to master branch. My origin is already configured with code commit, so I will just provide git push origin and then master. Okay, the code has been successfully pushed to code commit. Now let's go back to code pipeline. And let's go back to the pipelines in here and click on the pipeline again. And there it is. Pipeline has been triggered and the source stage started executing. Let's wait for it to get completed. And it has been completed. You can see it picked up the latest commit and our build stage has started. And if we check the build status by clicking on this link, and if we go to the latest build which is being running, you can see the tests had run and all the 8 tests had passed. All right, the build has also completed. Let's go back to code pipeline. It's still running, so probably waiting for the status to get reflected here. And there it is. The build stage has also completed. Our deploy stage has started. And if we check our load balancer URL, it says temporarily out of service, which means the instances are being drained out from the load balancer. So let's come back after the deploy stage has been completed. All right, deploy stage has been completed as well and our pipeline executed successfully. Let's go back and now refresh the load balancer URL again. There it is. Our title heading, which we added, has been deployed successfully using AWS CodePipeline without any manual intervention. This is how we can automate the deployments or the continuous integrations using CodePipeline from the source control system till the production environment. Okay, let's quickly see some important features provided by CodePipeline. And if you go back to our pipeline, from here you can disable transition from one stage to another. Let's say for a certain period of time, you want to perform continuous integration operations, which involves only source and build stages, right? So you can disable transition here so that none of the changes will be deployed to any of the staging or production environments. And let's say your development is complete and you're sure to release the code. You can enable the transition back and the transition to deploy stage triggers immediately, but with the latest revision that ran the build stage, which is your final revision of the code. You can also edit the pipeline and you can add multiple stages in here. Let's click on add stage here. And let's say you want to perform some pre-built activities. So let's add this stage. So stage itself does nothing. We need to provide one or more actions to be performed when the stage gets executed. So you can add actions from here. So you can give it a name and you can select actions from here. These are different action types which we discussed in the presentation. You can select the relevant action. Let's say we want to create an image of existing instance before we build our code. We can choose AWS Lambda. And then we can configure input artifacts and then a function name and then the output artifacts name and hit save. I forgot to give the name, so let's give it a name and then hit save. The action has been added. So not only to the new stage, you can also add actions to existing stages from here. And you can save it. And that's about how we edit a pipeline. All right, that is it about AWS CodePipeline. The developer tools provided by AWS, which are Code Commit, Code Build, Code Deploy, and Code Pipeline, are very effective services to perform CI/CD operations on AWS platform. They are also very important topics for the examination. So I suggest please go through each service, read the FAQs, and practice as much as you can to remember the configurations and different combinations of deploying and building the applications. Hope you enjoyed this lecture. Thanks for watching.